mathematics immediately. The topic today is equation of the tangent of a circle. Now when you say tangent to a circle, a tangent is a straight line that touches a circle at just one point. So we want to find the general equation of the tangent of the circle. Now the coordinate point is x1, y1. So it is the equation of a circle, x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. At this point, we replace x and y with x1 and y1. So we have x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus c is equal to 0. The first thing I want to do is that I'm going to make c, which is your constant, as something of the formula. So we have that c is equal to minus x1 squared minus y1 squared minus 2gx1 minus 2fy1. So c is equal to minus bracket, you factorize this, x1 squared plus y1 squared plus 2gx1 plus 2fy1. This is equation 1. The next thing I want to do is that I need to get the gradient at this point. And the gradient is what I call the y dx. So I'm going to differentiate. Now you have the y dx is your gradient. The y dx is also y2 minus y1 over x2 minus x1. So since we have that the point is x1 and y1, I'll take my gradient as y minus y1 over x minus x1. This is what I'm going to use for the gradient. But initially, I need to find the y dx from the equation of your circle. Now your circle, x squared plus y squared plus 2gx plus 2fy plus c is 0. This is an implicit function. When you have an implicit function, you have more variables, not just x. You also have y as a variable. So when I want to differentiate this, when you say differentiate, for instance, if y is ax raised to power n, so to differentiate means the y dx, this power you multiply this, n times this, you have n ax, subtract 1 from the power, that's n minus 1. This is differentiation. So to differentiate an implicit function, whenever you differentiate your y variable, you attach the y dx. So 2 times x is 2x, 2 minus 1 is 1, you don't have to write that, plus 2 times y, that's 2y, attach the y, the x, plus differentiate x, 2g is a constant, to differentiate x, 1 times this, you have 2g, when you subtract 1 from the power, you have 1 minus 1, that is 0, x raised to power 0 is 1, I don't have to write that, plus differentiate y, you have 1, that's 2f, because it is y, you attach the y dx, and when you differentiate a constant, you have 0. So I'm going to make the y dx as the subject of the formula. But I can see that 2 is a common factor. So divide through by 2. So 2 here you have x plus 2 plus y dy dx plus g plus f dy dx. I want to make the y dx as a formula. So we have the y dx in 2 places. So y dy dx plus f dy dx is equal to x comes here minus x minus g. So dy dx, you factorize here, you have y plus f into minus into x plus g. Therefore, dy dx is equals to minus x plus g over y plus f. This is the equation of your tangent. But we have to do some other calculation here. We continue from here. We said the y dx is also y minus y1 over x minus x1 is equals to minus x plus g over y plus f. Now this is the equation of your tangent. This is the equation of your tangent. So cross multiply to solve further. Y minus y1 into, now this is y. So at x1, at this point, x1, y1, so that means this will be x1 and y1. So I have y minus y1 over x minus x1 is equal to minus into x1 plus g over y1 plus f. So you cross multiply y minus y1 into y1 plus f is equals to minus bracket x minus x1 times x1 plus g. So y times y1 is y1 plus yf minus y1 times y1, that's minus y1 square, minus y1 times f is minus y1 f is equals to minus big brackets. So x times x1, x1, x times g is plus xg, minus x1 times this is minus x1 square minus x1g. So we have y1 plus yf minus y1 square minus y1f is equal to minus times this minus x1 minus xg, minus times minus is plus x1 square, minus times minus is plus x1g. So we have that y1, so y1 plus yf minus y1 square minus y1f is equals to minus x1 minus xg plus x1 square plus x1g. Minus x1x comes here, you have x1x plus y1, then you have minus xg will come here plus xg plus yf, that's yf is equal to x1 square minus y1 will come here plus y1 square. Then what do you have left? We have this will come here. We have plus x1g, the minus y1f comes here plus y1f. So this is equation 2. Recall that c is equal to minus x1 square plus y1 square plus 2g x1 plus 2fy1. This is equation 1. Recall from equation 1. So when you compare this and the right hand side, you have x1 square, y1 square. We only need x1g to be 2 here. And we need y1f to be 2 to complement here so that we can have c into the equation of the tangent. So that means I need x1g plus y1f. So for this equation 2, add to equation 2 x1g plus y1f to add to both sides. So we have x1x plus y1 plus xg plus yf plus x1g plus y1f is equals to x1 square plus y1 square plus, when I add that to this, you have 2x1g plus 2y1f. So when you compare this with equation 1, you realize that this one is this. That means this is minus c. If it minus c will give you this sum, which is this. So that means that x1x plus y1 plus xg plus yf plus x1g plus y1f is equals to minus c. So let's look at terms that are common here. We have these two, x1x plus y1y. Then we have g's here and we have g's here. So when you collect this together, you have xg plus x1g, that is plus bracket x plus x1 bracket g. The other one you have is yf and y1f. When you factorize this, you bring out f, you'll be having inside bracket y plus y1, that's plus y plus y1 into f Bring minus c here, you have plus c. This is equation 3. This is the equation of the tangent. This is equation of tangent of a circle. That is x1x plus y1 plus s1g plus y1f plus c is equals to 0.